So in the last video, we talked about the idea that we might be able to show that some variables are related. Like we could show that eating spinach is related to having a higher IQ. But just showing that variables are related doesn't necessarily show that one of the variables is causing the other variable. Changing the amount of spinach you eat causes a change in your intelligence. We can't conclude that from the kind of study that just looks at whether variables are related. So we need to do a special kind of study, and we said the kind of study we need to do is what we call an experiment. And again, you will see the term experiment thrown around a lot. And in the casual sense, we often use it to just essentially mean the same thing as a study. We'll often refer to non-experimental studies as experiments when we're just talking about it casually. But in science, when we really look at the technical definition of an experiment, the purpose of an experiment is to show that one variable causes, that changes in one variable cause changes in another. It's to prove a causal relationship. That's the point of an experiment. So let's talk about how you would go about doing this. First, just to get some context for this, we have to think about what is it that's problematic about our approach when we were just looking to show that there was a relationship between variables. Because an experiment is going to look very similar. One of the approaches we took was to divide people up into groups and compare the two groups. So we said some people eat spinach, some people don't eat spinach. Those are our two different groups. And we're going to measure IQ, and we're going to make a comparison that shows there's a difference between IQ, between the two groups. And based on that, we can say that there's a relationship there. And we're going to see that when you do an experiment, you end up with results that look very similar, where you are making a comparison between groups. And based on the fact that there's a difference between the groups, rather than just saying that the variables are related, you're going to say because there was this difference between the groups, something must have caused that difference, and we know what that thing was. We can show which variable caused that difference. But the question is, why can't we do that here? Why are we not justified in making that conclusion here? And one of the issues is that we can think of it as this being time 1 and this being time 2. By time 1, I mean before people came into the study, this is what they looked like. And after they came into the study and we measured them, this is what they looked like. In other words, they're the same. They're identical. People who ate more spinach were smarter to begin with. We measured them. We found out they ate more spinach and they were smarter. There was no change. People who didn't eat spinach were less intelligent to begin with. They came into our study. We found that they didn't eat spinach and they were less intelligent. And the fact that we didn't change anything or manipulate anything is the reason why we're having trouble proving causation. So the alternative is instead of trying to find out how people already are, we say we don't really care too much about how they already are. We're actually going to just randomly scramble everyone and assign them to two different groups. So we're assigning them to these two different groups down here randomly. We just pick people at random to put into group 1. We pick people at random to put into group 2. And that's what these G1 and G2 down here mean. When we do that, what we're going to end up with is we're going to end up with a mix of people who eat or don't eat different amounts of spinach in each group. So the amount, the spinach eating behavior is going to be on average about the same in both groups. And we're probably going to end up with the IQ being about the same in both groups. And that is why you see that the level here is about the same. Then what we're going to do is we're going to deliberately manipulate one of the variables. In this case, we're going to give group 1 spinach. We give them spinach. We actively increase the level of spinach that they consume. Maybe they already ate some spinach, maybe they didn't. We're going to make sure now that they eat more spinach than the other group. So this was time 1, right? This was time 1. Before they came into our experiment, they looked like this. Then we gave them spinach. And then we see after we give them spinach, if we measure them at that point, we should see a change. So this is the group that got spinach, and we see this difference, but now we can make a conclusion about that difference. The difference was not there before. The groups were the same to begin with. We manipulated one variable only. We gave them spinach. We increased the amount of spinach they ate, and after that, only that one variable increased. We then saw an increase in intelligence. So the idea of just changing one thing, well, everything else stays the same. Well, the participants are on average the same between these two groups, and just changing the one thing, if we get a change in something else, we can say, we should be pretty confidently able to say that the change we made, the thing we manipulated, in this case giving them spinach, that change caused the other change. So that is the key thing. Having groups that are about the same to begin with, manipulating a variable deliberately to change it, and then observing that change causes a subsequent following change that you're able to detect in the other variable. That's the point of an experiment. That's how you show that one variable causes another. And we'll get into this in more detail later on in terms of what are issues that come up with threatening that, with maybe your experiment is not going to work correctly. But for now, I just want you to have a general idea that an experiment is to show that one variable causes another, and this is generally how you would go about doing that.